In this example, we want to work with the polynomial f of x equals x to the fourth plus 2x cubed plus x squared minus 8x minus 20. And we want to go ahead and take this polynomial and write it in factored form. So let's go ahead and start with the degree. Our highest exponent on this polynomial is a degree of 4. So that means that when we're going to be factoring this polynomial, we're going to be looking for a total of 4 sets of parentheses and 4 zeros. So let's go on to step 2. We want to go ahead and list our potential zeros from this function. Now keep in mind, we want to go ahead and start with our factors of 20, which is our constant term here at the end. So our factors of 20 are going to be 1 and 20, 2 and 10, and then we have 4 and 5. Our leading coefficient in front of this x to the fourth term is really a 1, right? That's going to be our value for q. And the factors of 1 are just 1 times 1. And then we can go ahead and list our potential zeros. Remember that your potential zeros are in the form p over q, so it's each of these numbers where we had the factors for 20, so the 1, 2, 4, 5, 10, and 20, all of them we're going to be writing over a 1. And we're going to get both the positive and negative version of each of these. So we can actually go ahead and consolidate this list. Right, our potential zeros list in the form p over q. We're going to have both the positive and negative versions of 1, 2, 4, 5, 10, and 20. Once we have our potential zeros created, we want to go ahead and graph the function so we can take a look at the graph and find the actual zeros. And on our graph, we see that we have an x-intercept here at -2, and we also see that we have an x-intercept here at +2. Once we've identified some of our actual zeros, we can go ahead and start running these through synthetic division. So let's go ahead and set that up. Our polynomial is already in descending order, and we're not missing any terms. So our coefficients here are 1, 2, 1, -8, and -20. And I'm going to go ahead and run the +2 through synthetic division as my first zero. Let's go ahead and drop down our 1. We'll multiply to fill in our second row. So 2 times 1 is 2. And at this stage, we're going to go ahead and add. So that's going to give us a 4. 2 times 4 is 8. If we add, we get 9. 2 times 9 is going to give us 18. When we add this, we'll get 10. And 2 times 10 is going to be +20. When we add those, we'll get 0. And that's what we wanted, right? We knew it was a 0, so it should check out and give us a remainder of 0. So now let's go ahead and run our second x-intercept through synthetic division. I'm going to work from my answer right here. Right? Do not go back to your original. You want to be able to reduce this all the way down. And I'm going to go ahead and run the -2 through my synthetic division. So we'll go ahead and drop the 1 down again so we can get started. -2 times 1 is going to give us negative 2. Remember that you're adding at this stage, so this is going to give us a positive 2. We'll multiply here. Negative 2 times 2 will give us a negative 4. When we add, we're going to get 5. And negative 2 times 5 will give us a negative 10. When we add straight up and down here, we're going to get 0. Which we were expecting since we know that that was one of our x-intercepts. Right, and now we're at a spot where we're actually stuck. We've run both of our zeros through the synthetic division. We know we should have a total of 4 zeros because our highest degree is 4. But if we look at our graph is crossing at both the 2 and the negative 2. So there's no spot where it touches, so I know there's no multiplicity of 2, so now I'm kind of at a spot where I'm stuck. So this is where we're going to go look for the complex zeros, and what you're going to notice here is on this last line, you actually have the coefficients for a quadratic. Right, remember that the 5 is your constant, the 2 is your coefficient for your x term, and the 1 is your coefficient for your x squared term. Okay, so if we pull this quadratic out of here, we're going to have 1x squared plus 2x plus 5. And we want to go ahead and factor this. If we take a look at the 5, we do not have factors of 5 that add up to 2, so the only way we can actually get some x values here is to run this through the quadratic formula. So let's go ahead and do that. Our a value here is a 1, our value for b is a positive 2, and our value for c is 5. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, and all of this is over 2a. So let's go ahead and plug in our values here. We've got a negative 2 plus or minus 2 squared minus 4 times 1 times 5, and all of this is over 2 times 1. Alright, so we can go ahead and simplify what we've got. Underneath our radical, 2 squared is going to give us 4, and the 4 times 1 times 5 is going to give us 20. So we've got 4 minus 20, which is going to give us a negative 16 under that radical. And let's go ahead and break this apart so that we can work with that square root of negative 16 piece. Alright, remember that's going to be the same thing as the square root of 16 times the square root of negative 1. And we know the square root of 16 is a 4. Right, the square root of negative 1 is where we can replace that with the letter I. So our x values here, we've got negative 2 plus or minus 4i, all of that over 2. And keep in mind, when you go to simplify this, you want to divide each thing here by the 2. So this is the same as negative 2 over 2 plus or minus 4i over 2. Right, so our x values are going to be negative 1 plus or minus 2i. Okay, and there are your last 2 zeros. So let's go ahead and make our list here. From that graph, we knew that we had a 0 of negative 2 and positive 2. Those were the real zeros. And then for our complex zeros, we have a negative 1 plus 2i. And for our last one, we have negative 1 minus 2i. Right, and we want to go ahead and put this in factored form. Keep in mind in our sets of parentheses here, we want it to read x minus the 0. So for my real zeros, I'm going to go ahead and use parentheses. So I've got x minus a negative 2, which is going to make this an x plus 2. I've got x minus my positive 2. And then for my complex zeros here, I'm going to go ahead and use the brackets, because I have multiple terms here, so I can put this whole thing inside a set of parentheses. So x minus the negative 1 plus 2i. And then for my last set of brackets here, I've got x minus negative 1 minus 2i. And there's our polynomial in factored form.